Back. Now let's understand a little bit about expressions. What is an expression? It's just numbers with symbols. Okay. Now 14 plus 5 plus 3, it's an expression. So do we add from the left or do we add from the right? 14 plus 15 minus 2, same question. Do we add from the left or do we read from the right? 14 minus 15 plus 2. This is where you need order of operations. Okay, this I'm sure you have seen in your earlier math classes. Order of operations is also called precedence to evaluate. Now, addition and subtraction have equal precedence and are left associative. So you go from left, 14 plus 5, 19 plus 3. Or 14 plus 15, 29 minus 2, and so on. All right. On the other hand, exponentiation is right associated. This is something we have to know. Okay. If I have exponent followed by an exponent, then this is evaluated first, right? So that's as good as saying putting 3 star star 2 in parentheses. When in doubt, it's better to use parentheses always. Okay. Now, how do we portray evaluation? Well, if I want to, so here is an example of evaluation tree. Okay. Say I want to evaluate 1 plus 2 times 3. You know you're going to multiply first and then add, right? So that's why it is here. So the very first thing to do is 2 times 3. Okay. Whatever result I get, I'm then adding to 1. Okay, so that's an evaluation tree. So notice how the first thing done is lowest here in your drawing. The result is then combined with whatever. Likewise, here is an assignment. Full name equals first name plus space plus last name. So the assignment is always evaluated last. Okay. So not evaluated, assignment is implemented last. So you're going to first evaluate the right hand side. This is left associative. So first name plus space is the first thing that's evaluated. First name plus space, that's a plus. I get a result. That result plus last name is evaluated next. Then that result is assigned to full name. Okay. So this entire process can be rewritten as first name plus space first, then plus last name, that's the second set of parentheses, and then all of that is assigned to full name. Okay. So be mindful of how evaluations go when you code, because it matters. Your output has to matter. All right. Now, Boolean expressions. Boolean expressions I'm speaking, and that is the bool class. The literals true and false are instances of the class bool. The term bool is named after the mathematician George Boole, who pioneered the study of many logical properties. So there are 3 core logical operators. Not. This is unary, means not of one thing. That's one. Therefore, it is unary. And you talk about and of 2 things, something and something else. That's why it's called binary. Likewise, or is binary. Something or something else, right? So not is unary, but and or, these operators and or are binary. All right. So here is a truth table. I'm sure you're aware of this. Not x. If x is false, not x is true. X is false, not x is true. X is true, not x is false. X is true, not x is false. So on. X and y. What does that mean? Both have to be true for and to be true. Otherwise, it's false. So, both true gives me true. Otherwise, it's all false. No matter what x and both have to be true. Or x or y. Only one of them, as long as one of them is true, or is true. So, here y is true, or is true. Here x is true, or is true. Both are true, or is true. Both are false, or is false. This symbol means double equality means the conditional. Is it equal? That's a question. Is x equal y? Well, true, false, false, true. Okay. This means not equal. Is x not equal y? False, true, true, false. Okay, as long as x is not. So note that our or is an inclusive or. Okay, that is both true is fine. The exclusive or relies on both not equal. Okay, x and y simultaneously cannot be true. There are some compound Boolean expressions. 3 less than x and x less than 8. You can write this as 3 less than x less than 8. That's chaining. Okay, this is important. For example, if I ask 3 less than 5, true. 5 less than 8, true. 3 less than 5 and 5 less than 8. So that's a true, true and true, true. Okay. Now, all we are saying is instead of writing this entire thing, we can simply say true. Okay, so that is a valid expression. Chaining. Okay. Calling functions from within expressions. Okay. So, if I want to say length of groceries greater than 15 and milk in groceries, so that and is evaluated last. The rest are evaluated at the same level. Length of groceries greater than 15. Milk in groceries. Okay, so these are Boolean expressions, you see. And then that's your evaluation tree. So first these two, at the same time these two. Okay. Now note that when multiple function calls are used in the same expression, they are evaluated from left to right. For example, song equals with a moo moo here and a moo moo there. Suppose I ask you to split 5. What does that mean? So you have several things going on. That's a string. We are being asked to split it on space and then find index 5 item. So split results in a list and then find 5, right? So let's play with this, figure out, right? So, okay. Song equals with a moo here and a moo there. That's my song. What happens to song dot split? Gives me a list of words. That's what the default split is. So this list index 5 should be 0, 1, 2, 3, 4, 5. I should get and the word and I do. So notice how we understood this expression. We first split. So it is called left associative. So you're evaluating left to right. Okay. Suppose I ask you to lower it and then count t, little t. Okay. So what is my song? It's the same. I didn't change song. I just created here a list. Okay, but the song is same. So if I lower it and then count the number of t's, I get 2. There is a t and then there is a t. Is this clear? What is my song? It's still the same. All right. Now suppose I lower it and then split it. You figure this part out. Tell me what happens. Okay? Until next lecture now.